compound inequalities and solving compound inequalities. What do we think a compound inequality is? You can kind of tell just by looking at these notes. Miss Whitehead, what do you think? Yeah, we got two inequalities in one. Now, compound means like multiple, so we could have more than two, but typically in algebra you only see two. Okay? An example. 3 is less than or equal to x, which is less than or equal to 4. Two inequalities in one. We can split this to show the two inequalities. This would be 3 is less than or equal to x, and x is less than or equal to 4. All right, so give me a solution for this. What could x be? 3.5. The other one, Mr. Waller. What can x be? 3.2. Perfect. Can x be 2? But that's less than 4. 2 is less than 4, right? But it also has to be bigger than 3. This and statement makes it not true. Okay? So we can graph inequalities, compound inequalities, two inequalities in one. Okay? Our solutions here are bigger than 5 if I read this and split this up into the two pieces. My solutions are bigger than 5. Also, they are less than or equal to 8. So we got two numbers now that are important, 5 and 8. 5, of course, is the smaller number. 8's the bigger number. Mr. Green, am I going to put open circles or closed circles above 5 and 8? Closed circles. And what do you think, Mr. Green? How can I show this compound inequality on this number line? Yeah, you can kind of put the arrows. So this one would be like this, right? And this one would be kind of like this. Well, essentially, we're just connecting the two dots. Right? Doesn't that make sense, though, Miss Sudi? The line shows all of our possible solutions. What are our possible solutions for x in this statement? Give me one. Something between 5 and 8. 6, 7, 5.1, 7.9. These are all the points between 5 and 8. Yes, Ms. Whitehead. Could you go like this and have the arrows facing that way?
I mean, like the arrows, you know how the dots coming out, could you put like the arrows like touching the dots?
So could you go kind of like that?
Yeah.
The only problem with arrows is that arrows imply what? They go on forever. Exactly. So if I draw an arrow here, and let's say I draw an arrow like here, and maybe like I can go and like touch like that or something like that. Is that what you're saying? It's still implying that my solutions will go on forever, and that if I had 4 or negative 20 or any solution over here, that those are correct. So I don't want arrows because I do not want to imply that my solutions go on forever and ever and ever. Okay? So I really just want to connect, just like this. Okay? So that is an example of like an and statement. We have to be between 5 and 8. Here is an or statement. Well, we can see what x equals. Any number between 5 and 8, right? Yeah, any number, right? I plug in any number between 5 and 8, and that will work in this statement. Here, I'm told my x's could be less than -3, or my x's could be greater than 1. So let's think about some solutions. Give me a solution, Mr. Day. Is 0 less than -3 or? Good, -4 is a possible solution. Is 0 a solution? No, because 0 is not less than -3 or bigger than 1. Give me another one, Mr. Wilder. On the other side of things. 2, exactly. 4 is a solution, 2 is a solution. Really, we're just going to graph these separately and see what's going to happen. On my number line, I must know that -3 is a number less than 1. You must be careful with your number line. Smaller number to the left. Okay? My solutions being less than -3, am I going to have an open or a closed circle, Miss Tiffany? Open circle. And which way is my arrow going to go if I had an arrow? My solutions are less than. So you think I'm going to the right? Are these numbers less than -3? Left. Okay. Read it from left to right. My solutions are less than -3. Here's that. Here, my solutions are bigger than 1, or my solutions are bigger than 1. This could be correct. This is correct. It's not could be correct. This is correct. This is showing an or statement. My solutions are less than a number, or they're bigger than another number. So I can have numbers over here like -4, -5, -6. I could have numbers over here, 2, 3, 4, 5. They would satisfy this statement. So we have 2 inequalities in 1. Questions? Okay, you guys do these 2. You need to write it, especially that left one, as 2 inequalities. Do that. Just like you did the one above it. Or you can kind of just understand by looking at it, you can just draw. Yep. My solutions are bigger than -2, and they're less than 5. Go ahead and check your answers with a neighbor. I would be really careful with this bottom right one, because a lot of people put 5 on the left and 2 on the right. But you know that 2 is a smaller number than 5. Check your answers with a neighbor, please. Check Check that second one, Mr. Day. Yep, but don't draw arrows. Just connect the points on those ones on the left. All right, who wants to stand up? All right, Mr. Ascendis, go draw the first one. Mr. Wilder, go draw the second one. Beautiful. Open circle on -2, closed circle on 5, connecting those two. Excellent. A lot of people get tripped up because they put 5 on the left because they see 5 on the left over here. Okay? 5 is a bigger number. It should be over here on the right. Mr. Wilder, you were almost perfect. What happened? Beautiful. We got an open circle above 2 with our arrows going to the left, and then a closed circle above 5 with our arrow going to the right. Questions about that? Solutions are bigger than 5. Here are numbers bigger than 5. We got to get used to reading it from left to right or right to left. If we are going by the way the sign looks or something, you're just not grasping the concepts. So read it the correct way, and that will help you. If you split this into 2 inequalities, the first inequality you have to read from right to left. My solutions are bigger than -2. Well, that's over here. The second one, my solutions are less than or equal to 5. This is an and statement, so we have to be between. The or statement, we could be either to the left or to the right of 2 or 5. Okay. I could give you the picture and ask you to write the inequality statement. Go ahead and copy those down. If we are connecting 2 points together, we're going to have an and. If our arrows are going away from each other, we're going to have an or statement. Now, since we have 2 points, we're going to have 2 inequalities, kind of like up here. My solutions are bigger than 0. X is bigger than 0. And my solutions are less than or equal to 5. My solutions are less than or equal to 5. This is technically correct. Yes, Ms. Whitehead.
On the first one, why do you problem have and in it? It says
Here?
Yeah.
That's like an and right there. So what we're going to do actually, Ms. Whitehead, is we're going to start here, go here, and then write it like this. Okay? So Notice this is similar to the two above it, okay? We're going to start with this, write out our and statement, and then we're going to connect these two. We're going to say my solutions are actually in between 0 and 5. So that means they're less than or equal to 5. That comes from this part. And they're greater than 0. So I have to flip that sign right there and say it's bigger than 0, giving you this correct statement. My solutions are greater than 0 and less than or equal to 5. Cool? Everybody see that? Makes sense, right? Well, over here, this being an or statement, we write out our two separate inequalities. My solutions are less than or equal to -2, or my solutions are bigger than -1. And this is all you do. You cannot connect these two. It would not make sense. I could not put x and then have two things go the opposite way. We only connect if we have an and. We only have an and if we have 2 points that are being connected. Okay, so you guys do these two. I'm going to say -3 and 2. I'm going to go close. I'm going to go open. I'm going to connect. Here, I'm going to go 1, 2, open left, open right. Check your answers with the neighbor once you're done. So -3. Check your answers with a neighbor. You should get this as our solutions. Now, instead of leaving it as an and statement, I want you to combine the two and make it look like one single statement. So this is the correct way that I want to see an and statement. Or statements must be written like this. So combine these, like you see up there. Combine these. The x goes in between your two numbers. Your symbols end up going the same way. Yeah? No, you could say 1 is greater than x, and you can say 2 is less than x. Yeah. Everybody check up on these two and make sure you have these as your answers. If you have x is greater than 0 and x is less than or equal to 5, that's technically correct, but I want you to write it like this. This is a compound inequality. Okay? Solving compound inequalities. Remembering compound means we have like 2 or more. This is actually 2 problems in one. Okay? This is how we do something. We're told that x plus 2 is greater than or equal to 4. And x plus 2 is less than 8. What I will do is write out both inequalities as separate problems. So I have everything in the middle and the stuff on my left. 4 is less than or equal to x plus 2. That's my first one. My second problem would be everything in the middle and my stuff to the right. This second problem is x plus 2 is less than 8. Both of these are inequalities you can solve. And they will be solved the same way, because we just have 2 bothering my x in both problems. So to solve, I subtract 2 from both sides of both problems. Well, since these inequalities are connected, this is like an and statement, and this is like an and statement, and I can combine these two as my answer. My x's, my solutions, are bigger than or equal to 2, but they're also less than 6. So to show those solutions, on my number line, I have 2 and 6. My solutions are essentially between 2 and 6. 2 could be a solution, so it's a closed circle. 6 is not. Connect, and this would be your solutions to this compound inequality. Cool? Okay, you guys do this one then. And I want you to graph it on a number line that you draw somewhere. Start by breaking it up into 2 different inequalities, which I did up here, and then solve both the same way, and go from there. This would be 2x plus 4, this would be 2x plus 4. Everything in the middle goes for both inequalities. So you should have 2x plus 4 in both of them. You can do that, but people get confused when they do that and they make mistakes. So I prefer you not to do that. However, I can't stop you. If you get the right answer, that is. Sorry. 12 divided by 2, 6. 2 divided by 2, 1. Check your answers with a neighbor when you are done. You have to divide both of these by 2 so we can solve for x, right? We want x by itself. You're good. You just need to solve for x. Divide both sides by 2, divide both sides by 2. You get x by itself. You should notice that we're doing the same thing for both equations to solve. We're just ending up with 2 different inequalities. We subtract 4 and then divide 2 for both. We get x is greater than 1 and x is less than or equal to 6. So I could write that as 1 is less than or equal to x, which is less than or equal to 6. And I could graph that to closed circles above 1 and 6, connecting. Okay? We can do the second one. We have to start it out the same way. We get negative 4 is less than or is less than negative 2x, and we get negative 2x is less than or equal to 8. Mr. Havenga, in both inequalities, what do I have to do to get x by itself? Divide by what? Exactly. We have to divide by negative 2. And now, Mr. Havenga, what do I have to do when I divide by that negative? Flip the symbol. So when I flip, I get x is less than 2. When I flip here, I get x is greater than or equal to negative 4. Okay? This is also an and statement, and I also can connect these like this. Yep, if it's an and statement, they'll connect. If you have numbers between 2 points, they connect. If you have numbers that are like outside and going away from 2 numbers, like this, that's an or statement. Okay? Now, this is where people get confused, because they're used to drawing a solution like this, just like this. 1 is on the left, I put 1 on the left. 6 is on the right, I put 6 on the right, and connect the 2. Could I write my solution like this? No, cannot, do not. Negative 4 is the smaller number. It needs to go over here. 2 is the bigger number. It needs to go over here. Now, you are correct in saying my numbers are between those 2, but we are greater than negative 4 and we are less than 2. All right? I want you to do these 2 or statements. They're actually easier. And graph them. And then we'll be done for the day. And then you'll do your homework. And since this is an or statement, we probably should have lines going away from each other. So make sure you're graphing these correctly. Check your answers with a neighbor. For this inequality, I divide by 2. For this inequality, I divide by 3. On my number line, I have open circles with arrows going opposite ways. Here, subtract 4. Here, add 3. On my number line, I'd have closed circles going opposite ways. Question. If you have 2 lines going in the same direction, then technically only one of them you need. So typically no, Mr. Click, but you can kind of understand a situation where if this line here was instead like that, then it would cross over this 5, and really all you would need is this. Okay? But that usually does not happen. It's usually connecting or going away from. All right, stay in your seats, wait till the bell. Do your homework over the weekend.